Happy Monday, everyone. Thank you for joining us this morning or mid-afternoon, depending on where you're staying. Before I hand it off to Tim and Sean, just want to do a few logistical things, clear up a few logistical ends. First being that this call is recorded, so if you, and there is the chance that if you ask a question and things of that nature that your name and or email could pop up. So if that is something that you are not okay with, I would highly recommend you hopping off this call right now. Granted, this information will be available via slide decks on Yammer, and the recording is posted to YouTube shortly after, usually a few business days. So we'll have that information for you if the recording is an issue. Other than that, it'll be pretty straightforward. Sean's got some slides and a demo going for us. So if you guys have any questions, feel free to post those in the chat box, just so we can handle those on our back end, and then I'll cut into Sean's presentation to get those questions answered for you guys. And if there's anything that we don't get answered, we'll be sure to take those offline into the Yammer group just to kind of continue that conversation. But just as a quick last minute side note, just to make sure everything's working, to make sure the audio is working properly, if you guys wouldn't mind typing in the message box the color toothpaste to use this morning, that would be great. Thank you. And I'm not getting any messages, so I'm slightly worried that we might have an audio issue. Can everyone hear me?
I can hear you.
Huh. Maybe we just have a shy crowd this morning. Yes, they can hear us. Wonderful. Okay. Thank you. Thank you. There they come in. Perfect. Awesome. Thank you, guys. Well, with that said, Tim, I will hand this off to you.
Well, thanks, Parker. You know, I think it was probably because most people use multicolored toothpaste. It was a trick question. I think you posed that, Parker. Hey, I'm super excited for everybody to be here today and spend some time with us. Today, we're going to be talking about open source platform as a service on Azure, specifically Cloud Foundry, a very popular open source PaaS solution for large enterprise customers. I'm seeing a big uptick of this technology in the field, and because of that, I want partners to be aware of it and understand it, and perhaps maybe even think about building a practice utilizing something like Cloud Foundry and Pivotal Cloud Foundry. Just as a quick level set on community, this community call is a part of 3 channels, if you will, of our open source enablement team unit community. There's this community call. There is the Yammer group where we do a lot of our engagement and answering of questions. And also I produce a blog every month on certain open source technologies. Just a quick update on some of the updates that we've had on the Yammer. We just released some of the brand new Azure content. If you're looking for certifications on Azure, we've just updated that content, including free resources and some training on Azure. So I strongly recommend you look at the latest updates on Yammer. And also, I posted today on the Yammer site a great Channel 9 video that actually was reviewing Kafka on Azure through HD Insight. It's a great video and a great demo. We talked about this on our previous blog about open source fast big data. So please have a look at that. And with that, I will hand over to Sean McKenna, who's going to give us a good overview of Cloud Foundry and Pivotal Cloud Foundry on Azure and how that fits into the overall ecosystem in Azure. So with that, I'll hand over to you, Sean.
All right, so just let me know once you can see the front page of this deck.
Looks like it's beginning to load now, Sean.
Okay.
Start showing yet, Sean.
Okay.
You can try present again.
Try this again. I see a green bar around my screen, so that's a good sign.
Yeah, it looks like it's loading now. Starting to come through. There you go, Sean. Looks great.
There we go. Just had to wake up the internet hamsters. Okay, so thanks for the intro. So my name is Sean McKenna. I'm a product manager in the Azure Compute Group. I'm involved in a bunch of our different platform as a service offerings, both first party and third party. For the purposes of this call, I'm the product owner for Cloud Foundry and our relationship with Pivotal around Cloud Foundry. So I'll start by talking a little bit about what Cloud Foundry is. I don't have too many slides. I'm going to try to spend most of the time just kind of going through a little bit of the developer and operator experience, but just as context, so Cloud Foundry is an open source multi-cloud PaaS solution. It was originally developed by VMware, but has since become put into the hands of the Cloud Foundry Foundation, which is like most open source foundations, governed by a number of different companies, many of whom have enterprise distributions of the software, the most popular of which are from Pivotal and IBM, so Pivotal Cloud Foundry and IBM Bluemix. And then SUSE just recently purchased the Cloud Foundry assets from HP. As far as I know, they haven't named what their distribution is going to be called, but we can assume that that'll continue to be sort of the third player in the enterprise distributions. From the Azure perspective, we have a deep relationship with Pivotal, so we support both the open source Cloud Foundry, and then in terms of enterprise distributions, it's Pivotal CF or PCF. Cloud Foundry is deployable via Bosch, which is the Bosch outer shell, is a scripting language and infrastructure management layer that sort of provides the underlying foundation for Cloud Foundry. That's typically the way that you will deploy Cloud Foundry if you're working with the open source version, or if you want to have sort of full control. But typically with the enterprise versions, people will use some operational tools that are provided on top of Bosch, and we'll look at the Pivotal version of that in a second, which is called Operations Manager. As a modern polyglot PaaS layer, Cloud Foundry supports numerous languages and frameworks through a concept called build packs, which is basically the ability to detect the languages and frameworks that are included in an application, and provide all of the necessary supporting artifacts to run that application in a cloud environment. And so we'll look at that a little bit in a second, but you can think of this as being in some ways analogous to containers. Ultimately, what does get run in the Cloud Foundry environment is a container, but there's this additional value, which is that the build pack effectively generates the container for you. And so you get all of the necessary pieces that are required to run that application in that cloud environment. I'll show that in a second. In terms of Pivotal Cloud Foundry, just to kind of give you a sense of the different options, the most common place that this is deployed today, as with a lot of enterprise software, is on-prem in private clouds. That's moving increasingly towards the public cloud, and so Pivotal supports AWS, Azure, and GCP, among others. Interesting thing here from an Azure perspective is the AWS support is actually built by Pivotal sort of out of necessity. AWS has not really given them too much love, whereas ourselves and Google Cloud have actually built a bunch of the pieces that are required to operate Cloud Foundry on our respective clouds. And so that's kind of an interesting aspect of this environment. PCF Dev is a single box deployment option for running a stripped down version of Cloud Foundry for local development. And then you will see, if you go to the Pivotal website, you'll see talk of Pivotal Web Services, which is basically their fully managed environment that is typically used for POCs. We don't see many enterprise customers actually running production workloads there, but it is an easy way to get spun up and deploying Cloud Foundry applications without necessarily having to buy into a larger sort of infrastructure purchase. And then the last thing is we're working towards having PCF integrated with Azure Stack, so that when Azure Stack is available at GA, that you'll be able to deploy PCF through that environment as well. Just in terms of a little bit of the components that are involved, I'm not going to go through this full diagram, but just to kind of give you a sense, Cloud Foundry is not a single thing. It is made up of a number of different projects. And in fact, if you go to Cloud Foundry on GitHub, you'll see a bunch of these individual projects that get rolled together. So there's routing, there's authentication, there is the cloud controller, which is responsible for ensuring that the sort of desired state configuration of a set of applications that I've deployed is maintained in my cloud deployment. There's the notion of service brokers that I'll talk a little bit more about in a second, but this is a way that you can take advantage of external services and integrate those into your applications through a sort of seamless marketplace experience. And then something that's really powerful at the bottom of the stack is the notion of integrated logging and metrics. So you've got a large cloud deployment made up of a number of different machines and a bunch of different applications, but you still want to have all of that logging and metric information come together in a way that you can get a single view into your system. And Cloud Foundry provides a really elegant and extensible way of doing that. So with that as background, I think I'll just jump into doing some demos. My goal here is kind of just to give you a flavor of what the developer and operator experience looks like for PCF on Azure. So a lot of this will be common for Cloud Foundry if you're running it in other environments, which frankly is kind of part of the value proposition of Cloud Foundry, is that this PaaS layer is cloud agnostic. But I'll go into some of the details about the way that we've integrated with Azure, just so you get a sense of that. So to start with, from an Azure perspective, the easiest way to get going is we have Pivotal Cloud Foundry available as an offering in the Azure Marketplace. This will get you deployed with the Pivotal Operations Manager tool that I alluded to earlier, which is really the sort of the bootstrapper to get a full Cloud Foundry deployment set up. And I can show you here what the Operations Manager tool looks like. So it gives you this dashboard of your installation. Pivotal supports this notion of tiles, which are these little squares that you see on the screen here, which is a way of integrating different pieces of functionality into your Cloud Foundry environment. So what I've got deployed here is basically the core Azure setup, the Elastic Runtime, which is effectively the environment that's going to run our applications, and then the Azure Service Broker, which I alluded to earlier as a way of connecting out to other services from your application, and I'll show how that works in a second. The key thing to note here is As I mentioned, there's a bunch of different deployment options for PCF. This is basically a public cloud deployment where I, as the customer, own all of this infrastructure that the Cloud Foundry layer is deployed on top of. And just to prove that, we can take a look in the Azure portal, and here's the resource group that I've deployed my Cloud Foundry installation into. So you'll see a bunch of availability sets. I have a number of different VMs and IPs, and so all of this infrastructure is something that the Operations Manager tool will set up for you, but it is ultimately resources that you own as part of your Azure subscription. So this is not it's not sort of a fully managed abstracted service. It's running on top of IaaS resources that I own. So with that as kind of context, let's take a look at kind of what the developer experience looks like. And so I'm going to use the Cloud Foundry CLI to do a set of deployments and other operations. So we'll start with Java application. So I've got this sample app that's associated with the Spring framework. I should mention Spring is a set of frameworks that is independent but nicely integrated with Cloud Foundry and also owned by and managed by Pivotal, and makes it really easy to build applications and often microservice-based applications on top of Cloud Foundry. So this is a basic music store application built with the Spring framework. And so what I'm going to show is basically how you would go ahead and do a deployment of this application to Cloud Foundry. So the first thing I'll do is just create a WAR file, which is obviously the artifact for deploying a Java web application. And then all I need to do is CF push this application, give it a name, so I'll just call it Spring Music. And then I can pass in a manifest file. And actually, let's just take a look at what that manifest file looks like. And so it's basically, it provides a name that I can override. I can set the memory that I want to scope that application running to, and then the path to, I guess it's actually a jar, not a war, that I'm going to deploy. And so if I just push this application and pass in that manifest, Cloud Foundry will go through two stages. The first stage is it'll stage that application. So that's where it's going to take the bits that are that I built as part of the app, and then it's going to detect the build pack. So you'll see it's detecting this Java build pack version that's going to pull in all of the necessary components to actually run that application in the cloud. And so what it'll create in Cloud Foundry terminology is what's called a droplet. And once that droplet is created, which you can think of as very similar to a Docker container, it's going to deploy that or upload it into a blob store that's managed as part of the Cloud Foundry installation. And then it'll take that and deploy it somewhere into that Elastic runtime. And so the nice thing about this is you're basically getting this very nice abstraction, which is sort of living the dream of platform as a service, where I don't actually have to think about, as a developer, I don't have to think about what machines do I have available and what resources do they have. I tell the system, here's the memory requirements that I have, and here's my application. Go ahead and put it somewhere and get it set up so that I can actually run it, and that's it. And now the application is available and deployed, and so I can go ahead and launch it, and there's the app. So it's a single, from having my source code, it's one or two command line statements to having the application deployed into the cloud, available through the load balancer directly to my client here as the browser. But now, in this case, you'll see that I basically just deployed a single instance of this application. So there's one running instance out of one that I asked for. As I start to get more traffic to that application, I might want to expand that out. So horizontally scale it across the set of machines that I've got deployed as part of my Cloud Foundry installation. And so what I can do is just go ahead and spin up some additional instances of that application, which you'll see. So there's the first one that was running, and now there's a couple more that are starting up. And that immediately takes those instances that have been spun up, adds them into the load balancer pool for this for that DNS entry that we saw before, and effectively immediately triples my capacity. So there's now my 3 running instances. I can actually take a look at those instances through an operational tool provided by Pivotal, which is this apps manager. So there I see my Spring Music with the 3 running instances, and you can see the memory and disk usage as well as the uptime. And I can basically do the same thing from this interface and scale it back down. And so now I've gone back to that single instance. And so with this kind of foundation, I can really quickly be spinning up applications and tearing them down based on the demand that I have for my service, which provides really high developer and operator productivity, and really allows me to focus on building my application and not so much having to deal with issues of scale. While we're in this Apps Manager tool, I'll take a second to talk a little bit about some of the organizational constructs of Cloud Foundry. This is one of the things that makes it very popular among enterprises, is the notion that you can, within a single Cloud Foundry installation, isolate different organizations, and then within those organizations, different environments. And so Cloud Foundry has the notion of organizations and spaces. And so you'll see here for this particular user that I'm logged in as, I can only see a single organization. So you can imagine that I'm actually, from an enterprise perspective, as part of this demo organization. That organization has a quota in terms of the resources that it's able to use within that Cloud Foundry deployment that is set by the administrator of the Cloud Foundry installation. And then within that org, I've got a couple of different spaces that I can deploy to, and I can create more of these typically for different environments. So having dev environment, a QA environment, a production environment, and for each of those I can see the number of applications that are deployed and the proportion of the quota that I'm using. I have full control over the set of members of each of those organizations, and so quite a large amount of granularity that you can set within the organization, and this is really powerful, again, within an enterprise for being able to have a single installation that large installation that you're managing, but slice it up across the organization, and then be able to do things like charging back individual organizations for their usage without having to set up a whole bunch of different environments. So that tends to be pretty powerful. Okay, so that was a Java application that we deployed and scaled up and scaled down. But this is a Microsoft presentation, so maybe we should talk a little bit about .NET. So again, Cloud Foundry as a modern polyglot PaaS supports a bunch of different languages and frameworks. So let's take a look at a .NET application. So I'm going to create a ASP.NET Core web application. And we'll use the Bootstrap framework. .NET. So that's going to go ahead and create the scaffolding for a ASP.NET Core MVC application. If I go into that app, in the previous example, I showed a deployment of that Java Spring application using the manifest YAML file. That's actually an optional artifact. You can in fact just push an application directly from within the source code, and what will happen is Cloud Foundry will detect the type of application based on the code that's there, and also set you up with some default values in terms of the resource constraints. So I think the default is 1 GB of memory, for example. So very much the same thing here. You'll notice that, like we saw with the Java application, where it was pulling down the Java build pack, here it's pulling down the .NET Core build pack. It's installing the .NET CLI, restoring all of the necessary NuGet packages to make this application run. So it's running through the exact same staging process to create a droplet, which will then be uploaded into that image store, that blob store within the Cloud Foundry installation, and then deployed out to one of what they call Diego cells. So Diego is the orchestrator that's at the heart of Cloud Foundry, and so you have a set of Diego cells that are effectively the VMs where these applications run in a containerized way. So we'll give this a second to complete. While that's finishing up, actually, let me just quickly, since I was talking about orgs and spaces, so this terminal, I've got logged in as the CF admin here. And so if I go in here, I can see, actually, let me do orgs first. I can see the set of orgs that are part of this Cloud Foundry installation. So here, again, I'm logged in as the admin, so I can see all the orgs that are created. So I've got demo, which is the one that me as my individual user was able to see. But then I've got also demo 2 and system, and these are 2 orgs that my Sean Mick at Microsoft is not able to see. And so that just kind of gives you a sense of how you can isolate individual users within those org and space constructs. Okay, so our droplet has been created, and it's in the process of now spinning up that application. There it goes. Now I can launch this app, and we should just get the default ASP.NET setup. Yep, there it is. So again, super easy from create the application, CF push, and it's now available online. And I didn't have to go and pre-provision a space for it to run. I didn't have to configure anything in the load balancer. I just push the application, and all of a sudden it's out there on the web. So that's great, but obviously over time I'm going to not only want to scale the application as I showed with the Spring app, but I'm probably going to want to change it as well. And so one of the things that Cloud Foundry makes really easy is the notion of blue-green deployments. So being able to have your existing deployment, create a new version of the application, start sending some traffic over to that new version, and then slowly take away the old version. So let's take a look at how that would work. So I will make a change to this app. Let's see where it is here. Index. So this is just the HTML for that front page, showing the little carousel. So I'll just make a simple change here to say even on Foundry Save that. Now what I'm going to do is push again, but I'm going to push a new instance of that application. So what did I call this? cf.net, and here I'll call it v2. And this is going to run through the same process to stage that new version of the application and deploy it out to the Cloud Foundry installation, but it's going to give it a new endpoint, that's cf.net v2. And so that'll be available for me to go and do my testing, and maybe I could get some specific users that I want to go hit that specific endpoint to do so. But all the existing users that are hitting that cf.net initial endpoint will continue to go there for the time being. So let's finish creating that droplet. So again, one of the nice things, particularly for enterprise customers about Cloud Foundry, is I mentioned this whole process of staging and creating droplets, and then the way that it actually operates at runtime is very much equivalent to what you get with Docker containers. And in fact, Cloud Foundry is taking advantage of the same underlying kernel constructs in terms of C groups and namespaces to provide isolation for each of these applications. So as I deploy out the Java application, the .NET application, and later I'll show a Node application, those are running in isolated containers. But I don't necessarily have to go and containerize my application as part of my development and operational process in order to take advantage of that functionality. So for enterprise customers who have existing applications and aren't necessarily ready to go through the process of containerizing them, this provides a really easy way to just say, here's my source code, figure out a way to run it in a safe and isolated fashion in the cloud without having to do any real changes. So this should be up in just a second. There it goes. Okay, now if I open up this endpoint, we should see the modified version. Okay, so there's the change that I made. So now what I'm going to do, as I said, I've still got this original endpoint, right? If I hit that, I'll still get the original version. But now what I want to do is actually start moving traffic from that original sort of V1 endpoint and start shifting some of it over to the new version. And so I can do that by virtue of there being a routing layer that comes built in as part of Cloud Foundry that sort of separates out the endpoints from the applications that are running. And so what I'll do is go ahead and map a route to the new application. And what do I have to put in here? I put in the domain, CF apps. And that's going to be coming from the original app endpoint. So it's going to tell me that it already exists, which is fine because I know that. But then it's going to add a new route from the V2 of the application. So it might be a little bit hard to kind of picture what's going on here, but there's basically now this cf.net, .pcf apps, and so on, is actually going to be splitting traffic between the V1 and V2. I can still hit the V2 directly, but for that V1 endpoint, it's going to split traffic. And so we can prove that. It's usually better to do, open a incognito window here. .NET v2. And hopefully if I refresh this, so this, again, this is the v2 URL. If I refresh this, I should start to see oh, sorry, I want the v1 URL. There you go. If I start to refresh this, you'll notice that it's switching back and forth in a sort of load balanced fashion between the v1 and v2 applications. So at this point, I'm splitting that traffic. You can imagine I did some initial testing on the v2 endpoint, the v2 version of the application. Now I want to start splitting some traffic between the two. And now once I'm satisfied that the v2 is operating correctly, and I'm looking at all of my logging and metrics, and see that everything is shipshape, then I now want to remove the old endpoints, that all of the traffic starts going to the v2 version of the application. So I can do that by unmapping a route from cf.net, and I will pass in hostname and remove it from that v1 endpoint. So basically, that's removing the cf.net, that v1 version of the application, from the main URL. And so now I still have both apps running. So I still have the cf.net, original application running. It just, there's no way to get to it because the root has been removed. And so at this point, I might as well just delete it. And there it's gone. And so now if I go back and rerun this, I should get exclusively the v2 version of the application. So that's a way to really easily do blue-green deployments and be able, again, take advantage of this agility and desire to move forward really quickly with your application development, delivering new features, and not worrying too much about exactly how to set up the logistics of all of this, because that it's a non-trivial amount of work to make sure that everything is routed correctly through the load balancer. This is a sort of very prescriptive model for following that blue-green deployment pattern. Okay, so I mentioned that one of the advantages of Cloud Foundry is you don't necessarily have to containerize your applications, but of course a lot of enterprises are starting to containerize their apps. So I want to quickly show the way that you can actually deploy a Docker container to Cloud Foundry. So if you have a pre-built container that you're generating as part of a continuous integration pipeline, for example, you can actually push those out in addition to directly going from source code. So I'll just quickly do, again, another CF push. So it's a very consistent model, regardless of what type of artifacts you're pushing. So I'll create an application called Docker Hello, use this -o switch, which tells Cloud Foundry that I'm going to be giving it a Docker container, and then I tell it where to find it. By default, it'll look in Docker Hub. And so I'll just use the Hello World application available from Docker Cloud. So it's going to do much the same thing, creating the routes, binding that route to the application. It's going to go and pull down that container from Docker Hub. You'll notice that the staging process was very quick this time because it's not actually having to stage anything, because it's already basically got the container image from Docker Hub. So now it'll go ahead and spin that up somewhere in Cloud Foundry. And there it goes. And now, again, I should be able to launch that. And there's a Docker container running inside of Cloud Foundry. So again, regardless of what type of artifact you're pushing, whether it's a Java application, .NET, or even just a pre-built Docker container, very consistent model in terms of how you actually push it. You can take advantage of a lot of the same functionality in terms of blue-green deployments across all of those different models. Okay, so the next thing I want to show is basically everything that I've shown so far has been very much Cloud Foundry kind of stock standard integration. One of the powerful things about Cloud Foundry is the notion of service brokers, which I alluded to earlier, which is effectively a marketplace of external services that you can integrate with your applications. And so from an Azure perspective, that's very appealing to us because we've got a number of value-added services that applications can take advantage of that we can then meld into Cloud Foundry applications. And so we do that through the service broker concept. So we'll quickly jump back over here to the admin view because again, within this larger Cloud Foundry installation, there's a lot of power for the administrator to be able to isolate what different organizations can do. And so I can actually look at the set of services that are available for this Cloud Foundry installation from this admin view. And you'll see I've got a couple of different brokers deployed. So there's the App Autoscaler, which is a service from Pivotal, which enables an automatic version of that scaling that I showed earlier with the Spring Music application. And then I've got the Azure Service Broker here. And so you can see the set of services that are available today, and we're looking to expand this over time. But as of today, you get DocDB, Redis, SQL, Service Bus, and Blob Store. And within each of those services, there are multiple different plans tying into the different types of SKUs that are available for those services. So obviously SQLDB has the basic SKU all the way up to premium, and similarly for some of the others. And what I can do is the admin, what you can see here in the third column is third and fourth column is decide which organizations are going to have access to those different services. And so I can say, for in this case, the DocDB service is available to anyone, whereas the SQLDB basic is available to the demo org, but the other SQLDB plans are not available to anyone, and similarly for the others. So again, I've got a lot of power as an administrator to decide what's available and to whom. And so we can see that by jumping back over to effectively my developer view here. If I look at the sort of dev view of that list, which is CF Marketplace, I'll see the set of things that are available to me. So I'm going to see the DocDB, Redis Cache, the SQLDB Basic, but not any of the higher levels. And so this is giving me a view into the set of things that I've got available to use within my organization. So what I'll show now is how I can take advantage of these services from within an application. So what I'm going to do is take a Node.js application that has a need for a Redis cache and bind those two things together so that the Node.js application can actually use the Azure version of the Redis cache that we operate as a service. So to do that, I'll do cf create service. I have to give it the name of the service, which is Azure Redis Cache. I choose the plan that I want to use, and then I give a name to that service instance. So I'll just call this OSS Redis demo, and then I have to pass in a set of configuration parameters that are going to tell the service broker what region I want it to be in, what resource group, some of the details about the specific plan. And so actually go. just take a real quick look at service worker Redis. So there's what that configuration file looks like, the resource group, some of the parameters. And so I can create service, Azure Redis cache, basic, OSS Redis demo, and then I'll pass in that configuration file. Whoops. Azure instance ID exists. Oh, cache name. Yes. Let's try that again. There it goes. Now, that's going to go ahead and start to spin up. It will take probably a few minutes to get going. So I'll just reuse one that I created a little bit earlier, which is going to be going to so here I've got a really basic Node application that's going to take advantage of that that Redis cache. Let me just take a look here. So there, it's using Redis, and what's going to happen as a result of. So let me pull up the manifest. So again, I'm going to use the manifest construct, and as part of this, I can pass in the set of services that I've created. So I think the one that I created earlier is called Redis demo. This is the equivalent of the OSS Redis demo that I just created. By virtue of having this service listed in the application manifest here, when that application gets staged, Cloud Foundry will go ahead and bind the service instance of that particular name to this application. And what that means is it'll take the necessary configuration parameters for the application to be able to connect to that endpoint and make them available as an environment variable inside of that application container. And so you can see here it comes in through this vcap services environment variable, and then it's available within the property bag that I can pull out and use to connect to that service. And so now I should be able to do my standard push, and we'll just call this node Redis, pass in the manifest. And as this is spinning up, we should see the bind. So there it is. Goes by quickly. So binding service Redis demo, which was the name of that service instance that I had created earlier, to the node Redis application. And then once that application spins up, it'll have that set of connection parameters available in that environment variable for it to run. So we can quickly prove that by launching this application. Again, stupid simple, just takes key value pairs. Same name 7, 15262, submit that, and then I can query it back. Not the sexiest demo in the world, but it works. And so that's pulling the value back out of that Redis cache, which we can prove is actually running in Azure by going back to trusty Azure portal here. And actually we should start to see, there's that second one that I created. This is the one I was using initially, and here's the second one that I spun up just a couple minutes ago. So really quick way to create services that are external. So these obviously are running separately in Azure, not part of Cloud Foundry at all, but quickly bind them into applications that I can use in the Cloud Foundry context. Okay, so that's been largely a kind of developer view on things. Obviously, there's also an operational aspect to any type of cloud deployment. And so Cloud Foundry offers a really simple way to get application logs directly from the CLI. So I can look at the logs for that Node-Redis application directly here. So you'll see the requests that were coming in. And this provides a kind of quick and dirty way for looking at the logs of the application, and I could do similar logging for a bunch of the system components. But obviously, over time, this is not a great way to monitor applications. And so what we've done is build a plugin for the Cloud Foundry logging infrastructure to pump these logs into Microsoft Operation Management Suite, which is our single pane of glass operational dashboard, which I come over here. So here's just an example of some of the visualizations that I can do. Here I've got like the API calls per application broken down. I can do response time for individual applications, and you can build out all kinds of different visualizations based on this. And I can do full searching of these logs from within OMS. So again, the same logs that I'm seeing there on the command line being pumped into OMS for me to do much more interesting analytics and have sort of a historical view of all of those applications. Actually, let me switch back real quick to one more developer kind of angle that I missed out on. I'll jump back to the music application that I showed before. So obviously, I've been doing everything from the command line here in terms of doing CF push, which is really cool and great and simple and easy. But obviously, in a real-world environment, you'll probably be doing this in an automated fashion based on source control. And so let me quickly show one other integration that we've done, which is with VS Team Services. So within this Java application, I'll go ahead and make a change to something similar to what we did with the .NET app. It's under resources. So I'll just go in here and that change the header here to be v2. And then commit this and push. And now if I go take a look at VS Team Services, which is over here somewhere, I've set up an endpoint for this particular Cloud Foundry installation. I'm using an extension that's available in the VS Team Services Marketplace to enable this integration. So I set up this endpoint within VSTS, and then I can create a build that will be triggered based on the check-in that I've made to GitHub. So I've connected GitHub with VSTS, and then I've connected VSTS with that Cloud Foundry endpoint. And so once this is able to get an agent to do the build, it will go ahead and do that packaging and then effectively do a CF push, the same thing that I was doing from the command line, but here within VSTS. And so you'll see very much the same output in this console window as what we saw from the command line. So it's doing that Gradle step, and then we'll start to do the staging operation, create the droplet, and push that out. And all of this is actually running on a BSTS hosted build agent, so I didn't have to set up a separate build agent. But this really makes it easy to do continuous integration, continuous deployment from BSTS. And obviously, you could use other CI/CD tools as well, but we wanted to make sure that this worked really well with our tools. The last thing I will show, I know we're running short on time, is on the operational side. Obviously, we've got OMS, we've got all the logs that are coming in, but there's still the potential that something could go wrong. And so for that, you are going to want to get support. And so what we've done is created the ability within the support workflow in the portal that I can then create a support request for Cloud Foundry. So here I can choose a VM running Cloud Foundry and go ahead and submit that support request. We've done a bunch of work with Pivotal to make sure that our respective support teams are highly trained on the technology on the other side, so that when you submit a request for a VM running Cloud Foundry, that the Microsoft support engineers are familiar with Cloud Foundry and understand how to do some basic investigation. And the flip side, that if you report an issue to Pivotal and it ends up being on the Microsoft side, that there's a seamless integration and handoff that happens there. So with that, I will really quickly jump back to the slides to give you a sense of where PCF and Cloud Foundry kind of fit into our strategy. And it's really about making sure that we're meeting customers where they are. So regardless of what framework or device or platform you want to run on, we want to make sure that there's a great story there within Azure. This is basically where we see Cloud Foundry fitting into the overall compute portfolio, where basically the things that are above the line are our fully managed services, so things like app service and functions, where it's really just focused on the application and there's no sort of operational aspect to it whatsoever. Below the line is the cases where you actually own the virtual machines that the abstraction is running on. And so we see Cloud Foundry as being roughly in line with something like Service Fabric, maybe to a lesser extent Container Service, but generally in that part of the stack. So we've been working with Pivotal for about a year and a half now, recently GA'd, including that operations manager tool that I showed you. So that makes it much easier to set up a Cloud Foundry installation, a Pivotal Cloud Foundry installation on Azure. And we've got a number of tier 1 enterprise customers that are deploying in production on top of that, including Ford, which is one of our largest, and then GE is actually in the process of bringing their Predix platform, which is their industrial IoT platform, based on Cloud Foundry to Azure. So that'll be something that lands probably mid next year. So a bunch of really large enterprise customers betting on this joint stack. And then the last thing I'll say is we're continuing to invest in the partnership and doing things like having co-located engineering, investing in some of the service brokers that I talked about, and doing things like building out shared reference architectures that will make available so that people get a sense of what the best way is to run PCF on Azure. So with that, I know we're a minute over time, but if there are any questions that people have, I can take those.
Sean, I want to thank you. That was an absolutely awesome demo. I think you went through everything that you said that you would. That was brilliant. You kept to the time. So I don't think we have any questions currently right now, but I think the epiphany that I had, Sean, was what you demoed, which was the ability for enterprises to have that departmental control. seems very key, right? Actually, I don't see that much in any other solutions out there. Is that the thing that's resonating with the enterprises with Pivotal?
Yeah, it definitely is, because the types of enterprises that they talk to typically are Fortune 2000, so very large enterprises with large IT departments and individual product units that are looking to those IT departments to provide them with a platform to deploy on, but still want to have isolation in terms of who's actually paying the bill for the usage. And so, yeah, that's been a very effective selling point for them. It's something that we're looking to, in terms of our roadmap, and providing a sort of better together story with Cloud Foundry. It's something that we're looking to sort of double down on. Can we do deeper integration with that organizational model in CF to our billing system, for example, or integration with Azure resource groups, which are sort of our way of providing that level of isolation. So yeah, we're looking to embrace that model as much as possible.
Yeah, and I think that's interesting from a partner perspective as well, because I think a lot of partners on the dev side, they see this over and over again, especially large organizations trying to solve that problem. So this has been fantastic. I want to thank you again, though, Sean. This has been brilliant, and everybody that's attended, so thank you for your time. Again, we will post the slides on Yammer, and we will also be posting the video of the demos, etc., on YouTube. So you'll see that shortly. With that, we'll close the session. Thanks, Parker, if you could do that.